Hey everyone, I'm looking for Dr. Romano again. It's over there. That looks like some boats. He doesn't like the boat. Oh, I think I see his car. It's got to be around here. Maybe he wants a little lunch. Hi, Dr. Romano. I'm going to have lunch. Can I bring you something?
Hi, how are you? I would like to go over the Diekmann reaction. So let's get right down to work. The Diekmann reaction, I get a lot of questions on with students in the study group and even emails. It's one of the least liked problems in all of organic chemistry. What we're basically going to do in a Diekmann reaction is we're going to do a simple internal Claisen. Now, when I do the Diekmann reaction, you're going to look for a diester. And I'll show you it's going to be a special diester with a span of 4 or 5 carbons. And what we're going to do is we're going to form a 5 or a 6-membered ring. So come along and I'll show you what we have here on how to go about doing the Diekmann reaction.
Okay, Dr. Romano, I liked your shirt today.
Now, this is what it's going to look like on the DAT exam. We give you an ester. But notice this is a diester. There's an ester on both sides, and there's my carbon span of at least 4 carbons. And notice I'm going to treat it with a base that matches the OR group of the ester. Here it's an ethoxy group, and here we have sodium ethoxide followed by acidification. So what we're going to do, the first move is to draw this out so you can see it a little clearer. So the CH2 taken 4 times, notice I just expanded it out. Now, I'm going to basically do what's called an internal Claisen. In English, what that means, I'm going to take the O-ethyl from one side, or it could be O-methyl, but here we have O-ethyl. I take the O-ethyl from one side and the alpha hydrogen from the other side. Now, when you take them off, this is what you would have. And I numbered the carbons 1 through 6 so nobody gets lost. So when I pull off the ethoxy group, there's my number 1, and then there's my C2, C3, C4, C5 span. Notice the H is off of number 5. And notice now what I'm going to do is make what I call a love connection. Number 1 loves number 5. So what's going to happen? They're going to join together. So follow me along. There's the C double bond O. There's the carbonyl. There's my number 1, or there's my number 2 carbon, I should say. Then the 3, then the 4, and then there's the 5, and then the 5 is connected to 1, and coming off the 5 would be the C double bond O ethyl group. And then just to make it look nice and pretty, you just make it into a 5-membered cyclopentane ring. There's number 1, as you can see. There's my 2, 3, 4, 5, and then coming off it would be the 6 and O-ethoxy. Notice we formed a 5 or a 6 member.
Is that the love connection?
Yes.
Okay.
Now, notice we formed the 5 with a 6-membered ring, and as you can see. Now, for homework, what I want you to do...
Okay, let me get... I have to get this whole thing here.
I want you to practice this. It's almost the same question, but notice the span is 5 carbons now. So what you're going to do is you're going to see if you do the same thing as I just showed you, write it out, make your love connection, and what you'll do is this should be your final answer, this beta keto ester here.
Okay, got it.
Now, for the students that want to see the mechanism on this, let me just show you how I went about doing this. As you can see from the first example that we did, we'll use that as our example, the O-ethyl group, or the ethoxide, acted as a base, and it removed off the acidic alpha proton to give the ester enolate. There's the ester enolate. It would have resonance, but I didn't show that. I just wrote etc. And now I do my intramolecular attack. Notice I use this carbon, which we called number 5 before, if you remembered, onto carbon 1, and I cyclized it. Then I form my carbonyl compound by expelling the ethoxide. And ethoxide, as you know, is a strong base, comes back, removes off the acidic double alpha proton, and then you simply reprotonate. You're not going to have time to do the mechanism, but it's good to understand the mechanism for the DAT exam. If you understood what I just showed you here, and you understood the ones that I gave you in the DAT Destroyer, this will be an easy question. It's in one of the top reactions in the Destroyer book. I say to make sure you know how to do the Diekmann reaction. It's a critical reaction. So in addition to the Diels-Alder reaction, forming a 6-membered ring or an aldol, we can also use this big reaction called the Diekmann condensation. All right, good day to you. I hope this helps.
Should I leave now, Dr. Romano?
Yes, you can leave. I'd like to get back to studies. Good day
I'm
to you.
coming back later, okay?
All right, bye-bye.
Bye. Good day to you, sir.